Good day, students, and welcome to our management information class. Today, the topic on focus is accounting for overheads. Now, overheads are those expenses that are made during a period, also called period costs. Overheads are not directly traceable to the final product, and so they are also called indirect costs, because those ones that are directly traceable to the product are called direct costs. These overheads are not directly traceable, and so they are called indirect costs. Now, how do we apportion or channel all the overheads incurred during a period in a production industry to the product? We do something called the 3 A's. First, we usually allocate. Now, by allocation, we mean that any department or cost center that has a specific expenses peculiar to it has to take that allocation. For example, you have two departments. One of them is the department of smoked fish, and the other department is frozen or iced fish. If you have repairs on refrigerator as an expense, you must give it to that department that is concerned with refrigerating. So you take it to the iced fish department, you allocate it to that. If you have firewood issues, repairs of firewood stove and all that, you take it to the smoked fish department. Now that is called specific allocation, or simply called allocation. Now that is the first A. The second A is called apportionment. Now in apportionment, what happens here is you cannot specifically allocate these expenses to a particular department. And so you kind of share it among them. Unlike the allocation where there is no sharing, in apportionment, there is a sharing. Say, for example, you have two departments I used before, smoked fish and iced fish, and they share a particular office space or a particular building. And you have your electricity bill. In Nigeria here, we call it NEPA bill. So let me speak like a Nigerian. You have your NEPA bill. Now, how do you share this electricity bill to the two departments? Of course, you cannot say that you allocate, no, because both departments enjoyed the electricity. But it's possible that one of them enjoyed it more. Maybe the refrigerator was consuming more power, and you need to consider that. And perhaps the only thing that the smoked fish department used was lighting. You need to consider the consumption. And so, consumption of electricity, the portion of consumption of electricity should be used. So you have a fair way of allocating, or sorry, I would say of apportioning this electricity bill. So we call that basis of apportionment. Now, if you are giving rent, you have to pay rent for that same building, How will you apportion the rent? The most conventional way is to use the floor area occupied by each of the departments. So if the smoked fish department occupy a large part, maybe because it has to store firewood, store other things that are, you know, too big and occupy space, and maybe the iced fish just have a small space just to keep the fridge and all that. You need to consider the area occupied by the department for you to allocate the rent. I keep using them interchangeably, sorry, for you to apportion the rent. So take note here, allocation, non-sharing. You give it or you charge it to the department that rightly has it. Apportionment, you look for a fair measure or basis to share. Now, apportionment is the second A. The third A is absorption. Now, in absorption, this is where the final product takes the cost. It takes it in so that you can know how much it costs to make the product. Now, it is easy for direct costs to be absorbed by the product because they go directly. But the the other one, which is the one that is being shared, it is not easy. So we use something called the overhead absorption rate, OAR. Now that is a different topic or a different explanation for another day. If you want to learn about absorption costing and perhaps compare it with activity-based costing, I have a video specifically for that. So our concern here is not using the OAR, it's for knowing how we can apportion and deal with apportionment. Now, during your apportionment, you have production departments and you have service departments. The production departments are largely concerned with the production of the final product, which is what is your main concern. The service department provides service to the production department so that they can thrive. And so you have production departments, then you have perhaps stores where the production department gets serviced. Then perhaps you have uh, maintenance that maintains the store, that maintains other production departments. Or you could even have canteen. And so, how do you allocate, apportion, and more especially absorb from this production and service department? For allocation, you have nothing to do. You allocate the cost incurred to all the departments, both production and service departments. When it comes to absorption or apportionment, you apportion to all departments concerned based on the appropriate apportionment basis. Now, after apportioning, you get your total cost for all the departments, production department, and service department. There is a need for you to remove all the costs incurred by the service department and take them to the production department. Why? Because service department do not have any business to do with the product. It's the production department. But why will service department be holding a cost? It is because they are cost centers. So there is a need for you to nil off the cost incurred in the service department and channel them to the production department. And there are three methods we will use in doing that. Now that brings us to our example one, which is Black Hole Company Limited. Now let's read this example and use it to illustrate the methods we are going to be using to reapportion, that's the word, reapportion the service department's cost to the production department. It says here, Black Hole Company Limited has service departments, namely maintenance, which is called M, and stores, which is called S, and three production departments, P1, P2, and P3. The service departments provide services for each other as well as for the production department. It has been agreed that the most appropriate basis of apportionment for the service department costs are capital equipment values for maintenance and number of requisitions for stores. The overhead applicable to each department following allocation and primary apportionment are, we have the departments here, we have their overheads and the total. Data for apportionment of the service department overheads. So we were told that to apportion maintenance, we shall use capital equipment values. And this is the capital equipment values that we can use in apportioning that of maintenance. Look at their proportion, 5%, 25, 38, 32. And we're also told that for stores, we use number of requisitions. And look at the number of requisitions, look at their percentages. Okay, so that's it. So what do we do? Okay, required. State three methods of apportionment of the service department to the production department. All right, so let's answer that question now. State three methods of apportionment of the service department to the production. So I'll come here now and start doing my solution. So this is solution to example one. And we know it as Black Hole Company Limited. So this is how we do it. The first part is asking us for the three method of apportionment of service department. So three methods of apportioning, I will call it now secondary apportionment. Why am I calling it secondary apportionment? Look at this statement here. They said the overhead applicable to each department following allocation and primary apportionment. So what they mean here is there was an allocation where they were sharing the costs. The costs that are allocated, we don't know all the cost elements. There could be rent, there could be lighting, there could be any other thing. The build up, we don't know the build up, but these are their totals. Direct allocation was made in some, and in some of them we have apportionment, primary apportionment. So in this apportionment, we use the basis of apportionment. If there was rent, we have used floor space. If there was electricity, we have used energy consumed as the appropriate basis and all that. We are not giving all of that information, but this has been done for us. So we have the primary apportionment and the allocation already done. We got the total. Now, because we have service department M having a cost and another service department S having a cost, we need to apportion these to the production department. So we'll do a secondary apportionment. So that's why I'm saying the method of secondary apportionment of the service department cost to the production department are one, we have the continuous method. Two, we have the elimination method. Then three, we have the simultaneous equation method. All right, we have answered the first part of the question. We've stated the methods. Now we want to apportion the two service departments, which is for the B, using the three methods described in A above. So as I'm doing the B, I'll be explaining how this is being done. So the B part says apportionment of the service department costs to production using continuous method. Now, how is the continuous method done? The principle in here is that appropriate proportion of the costs for the first service department is allocated to the second, and appropriate proportion of the second is allocated to the first department. And so there is a continuous of that until you have something insignificant. Okay, so let's bring them up now. M, S, P1, P2, and P3. So I'll bring them up here. We have M, S, P1, P2, and P3. Okay, then we have the overhead cost. Of course, it's in Naira. For that of the first one, which is M, we have 138,000. The 138, 136,000. So I have 136,000. Then the second one, which is S, is 54,000. P1, 240. P2, 390. And P3 is 520. So this is the costs. So you want to reapportion M first. So I'll say reapportion M. How will I reapportion M? I would say I'll use capital values. Look at the capital values for reapportion of M, as what is said. It means when I'm using the proportion of the reapportionment of, if I'm using capital values as a basis for reapportionment, it means that if I'm reapportioning M, I will take 5% of M's cost and give it to S. I'll take 25% of M's cost and I'll give it to P1. 38% of M's cost, I will give it to P2. And 32% of M's cost, I will give it to P3. So 5, 25, 38, 32. So I'll say 5, 25, 38, and 32%. So I am trying to reapportion M. I'm trying to reapportion M. So what it means here is M is going out 136,000. So let's look at the apportionment. We use the calculator. So we'll say 5%, which is 0.05, multiplied by 136,000. That will give me 6,800 for S. So this is 6,800. Then I will do the second one, 25% of 136,000. That will give me 34,000. Then I will also say 38% of 136,000. That will give me 51,680. Then I will do 32% of 136,000. That will give me 43,520. Now it's important to note that when you add everything, it should give us 136. When you add all the positive, rather, it should give you 136 so that when you are lessening it from 136, you have 0. So let's find out if what we calculated is correct. I have this last figure here. So I will add plus 51,680 plus 34,000 plus 6,800. That gives me 136. So I am correct. So after doing that, you will now add. So your M is now dash. So M is gone. You now have 54,000 plus 6,800. That gives you 60,800. So you have 60,800 here. Then you also have the other ones here. 240,000 plus 34,000. You have 274,000. So this is 274,000. Then you do the next one, which is 390,000 plus 51,680. You have 441,680. Then the last one there, you have 520,000 plus 43,520. That gives you 563,520. Now you've done the first secondary apportionment or reapportionment. You go again, reapportion S. Reapportion S. Now, what is the proportion for reapportioning S? It has been done for you, the proportion, so no need doing the proportion. But you may be wondering, how did we get this proportion? Okay, let's see how we got all this proportion. I'll just take one from each of the proportions. So let's see how we got this 5%. Let's see how we got this 5% so that we will know in case we are not giving proportion. So we'll do something like this. We'll add everything together. We have 30,000 plus 200,000 plus 1 million plus 1,520 plus 2, plus 1,280. That gives me 4,030,000. Now, but because these are the capital values, yes, but because we are using capital values to reapportion M, M should not be in the solution. So you see M here has 0. So we need to remove the value of M, which is 30,000. So the remainder, which is from S to P3, their value is 4 million. What is the proportion of their values? So for this is 4 million, which will be the denominator. Now let's look at S. It will be 200,000 divided by 4 million multiplied by 100. And that gives you this 5%. The same thing here with 1 million divided by 4 million multiplied by 100. But that gives you 25%. So that's how we did for all of them. Now, the same way here, we are going to be looking at 900 plus 24 plus 1620 plus 1080. Notice here that nothing was written for S. You see, because we are using this to reapportion S, so S should not be in the solution. So you can understand why we remove M in the first one, because M was not supposed to be in the solution. So we have 6,000 as our denominator. So how did we get this 15% here? 900 divided by 6,000 multiplied by 100. That gives you 15%. So that's how we did this proportion. So in case you are not given the proportion, you know how to do it. So now we just take this proportion, 15, 40, 27, and 18. So I'll come here. 15, 40, 27, and 18%. So what we'll do now is S is going, so you have to 60,800. So this is what we are sharing to all the other departments. So we are sharing it. So we have 15 divided by 100, which is 15% for M, multiplied by 60,800. That will give you 9,120. 9,120. So 9,120. Okay, we've done the first one. We come again. 0.4, which is 40%, multiplied by 60,800. That will give you 24,320. Then the third one here will be 27% multiplied by 6,800. That will give you 16,416. Then the next one here, 18% multiplied by 60,800. That will give you 10,944. Okay, so let's add them. The positive ones, let's see if it will give us a negative answer. Plus 16,416 plus 24,320 plus 9,120, 68. So we are correct. So what we do now is we will now, this will now be 9,120. Now this is dash. Add this up again. This would be 274,000 plus 24,320. But that gives you 298,320. 298,320. Then we have the 441,680 plus 16,416. And that gives me 458,096. Then the last one will give us 563,520 plus 10,944. That will give me 574,464. Now you see here, we have done apportionment of M to S, and we got 68. We now apportioned everything that at S have, and we apportion it, a part of it to M. There is 9,200. Now we are trying to eliminate M. As we are eliminating M, S is building up. As we are eliminating S, M is building up. We will keep doing it continuously until we have something insignificant. So we have 9,120 significant for M. We will now reapportion M again. We say reapportion M. Reapportion M. And we know that M, we have 5, 25, 38, 32%. So what we'll now have now is, this will now be negative figure 9,120. So we'll give 5% of it. So this 9,120 will multiply by 0.05. That will give me 456. So there is 456 here. We will now do the others. That one is 25%. 9,120 times 25%. That will give me 2,280. Then we have, the other one is 38%. So I will say 38% multiplied by 9120. That will give me 3466. Or let me say 3466. That's fine. Then we have 32%. 0.32 multiplied by 9120, and I have 2918. 2918. If I were to add all this, I will have 9120. Let's just test. 2918 plus 3466 plus 2280 plus 456. Good. So what happened now is you will add up everything again. This is now dash for M. S now has 456. And what happens to the others? Let's add them up. 298, 320 plus 2280. That will give me 300, 600. 300, 600. Then you will come again and 458096 plus 3466, 461, 562. Then the next one, you will say 574464 plus 2918. That will give you 577382. Now you have your reapportion M. You will now reapportion S again. Reapportion S. We know the proportion is 15, 40, 27, and 18%. So we know that S is 546. So this is what will go out here, 456 rather. So we are given 15% of that, 456 times 15%. That's 68. So you can give it 68 here. Okay. Then you have 456 times 40. That is 182. 182. Then we have 456 times 27. 123. And the last one, 456 times 18. I'll give you 82. If you add all of this, it will give you either 456 or nearly something near. So let's say 82 plus 123 plus 182 plus 68. What did I do? 68 plus 182 plus 123 plus 82, 455. So it's almost 456. So I can make any one. Let me make this 182. I'll make it 183. To whom more is given, more is required. I'll call it 183 here. And this will now become 68. This will be dash. This will be 300,783. Okay, this will be 461,685. So this will be 578 1. Let me not stress my brain. Let me calculate it, not to give errors. Just figures 577,382 plus 82. 577, 577,464. 577,464. All right, we have something here. Do you think 68 is significant? If you think so, we reapportion M. Continuous method. Reapportion M. And we know the proportion 5:25:38:32. They are all a percentage. Okay, so what we do now is 68, we give it 5% times 0.05. That will give you 3.4. Okay, of course, this 68 is going off here. So this is 3. Then we'll come again, 68, that one is 25 times 0.25. That will give me 17. Then there is 38%. 68 times 38. That will give me 26. Then we have 32%. 68 times 32%. That will give me 22. So let's add all of this if we get 68, just to make sure that we are correct. We didn't do anything wrong. We have 3 plus 17 plus 20, 26 plus 22. That gives us 68. And if you think 3 is significant, you reapportion S all over again. Reapportion S. So we have 15, 40, 27, and 18. All right, so we'll go. Let's start. We'll give 15% to, okay, so I didn't add all of these, so let me add them. So this is already dash here. This is 3. 3 plus 7 is 10. 8 plus 1, 9 plus the one you carried over, 10. 7 plus that one, 800. So this is 300, 800. 6 plus 5 is 11. 8 plus 2, 10 plus the one you carried, 11. Take that one to 6, it becomes 7. So I have 461, 711. 2 plus 4 is 6. 6 plus 2 is 8. Because there is 4 here. 577. So that's it now. If you think 3 is significant, so let's see 15% of 3. So you have 3 times 15%. That's 0.45. So at this point now, this is 3 is going off here. 0.45 is not significant. You just leave it dash here. Okay. Then you apportion 40% of 3. 3 times 40%. This is 1.2. So I'll just say this is 1. 27.27 times 3. This is 0.81. I'll still say it's 1. Then let me try 18%. 3 times 18%. 0.54 approximately to 1. So in this case here, this is now dash. This is now dash. This is 300, 801. This is 461, 712. And this is 577, 487. So we have completely, this is the overhead, total overhead. Now I want you to see here that the service departments are gone. The production departments are now having the cost. The total overhead did not change. Let's calculate the total overhead and see 300, 801 plus 461, 712 plus 577, 487. You see, the overhead is still 1,340,000. But you now see that the service departments are gone. The production departments are now holding the costs. So this is what we call the continuous method. You see it here that we continuously reapportion S to all the departments, giving a portion of it to M. S will go off, M will come into the solution, we reapportion M again. So that's how we'll be doing it until we get an insignificant number that we cannot approximate to a whole number. And that makes the two service departments fizzle out. So you're going to be going through iterative steps. It is good for you to know this method, although in your exam, you may not be asked to use this method, but you may need to know something about this method so that you can explain. And the best way you can explain is watching an example being done. So that's how we do the continuous method. We now go to something called the second method, which is the elimination method. So let's see the elimination method. So this, I will say this is B2 elimination method of apportioning service department costs to production. All right. So this is what we are going to do here in the elimination method. What we'll do here is we are going to look at the two departments. Now, this elimination method is used in two ways. One, whenever a service department service other departments and no service department is servicing it. Let's say we have 3 service departments and 2 production departments. The first one serviced every other one. Nothing, no other service department is servicing it. So we can take that one out first. Then we look at the second two. One of them will be servicing the rest, and the other one will not be servicing it. We take that one out next. Then the last one will just service the production department. Of course, production department cannot service it. We eliminate it third. So that's the way it is going to be done. That is when we have service department that are giving and not receiving services is best used there. Then in this second method where there is a reciprocal exchange of service, we can still use it. Now, this is where we are applying it now. So we use the elimination method to remove these costs. So let's look at how it is being done. This is M, this is S, this is P1, P2, and P3. Now let's look at the original costs. M1 and M is 136 originally. This is 136,000. So this is the overhead costs. This is 136,000. Then S is 54,000 originally. Then P1 was 240,000. P2 was 390. And P3 was 520. Now, similar to what we did in the continuous method, we want to eliminate one of these costs. Now, I will want to use my judgment and said because M has a large cost, let me eliminate M first. So I will say reapportion, reapportion, reapportion M. We know the proportion from what we did last, 5, 25, 38, 32. So this is 5, 25, 38, and 32. We've done it in the first time we did, but we'll note a difference when we do the second one. So this is 5%. So this is like 5 over 100 times, okay, times 136. That will give me 68. So of course this 136 is going. This is where the 68 is being applied. Okay, so you have 25%, 25% of 136,000, 38,008, 38,080. 38%, 38% of 136, 51,680. Then we have 32%. That gives me 43,520. Naturally, I want to check if I did the calculations well. I have this figure already. I think I did something wrong here. 68 plus 38,080 plus 51,680 plus 43,520. I did something wrong here. Let me redo the calculation again. I know that this 68 is correct for 25, coming 5 plus 25 plus 38 plus 32. Good, that's 100%. I know this 68 is correct. I remember that from the last time. 136,000 times 25%. Wow, it's 34,000. I think that's where the error came. 34,000. So this is 34,000. So let me add all again. I have 34,000. Let me add it to 68 plus 51,680 plus 43,520 520. Should be getting 136,000. So that's fine. So when I add here, this one is dash. So this is 54,000 plus 6,800. That'll give me 60,800. Remember that figure, 6,800. Okay. Then we'll need to do to 24,240 rather, plus 34,000. That gives me 274,000. Then we have 390 plus 51,680. What am I doing? 390 plus 51,680, 441,680. And the last one, I have 520 plus 43,520. And I have 563,520. Okay, so you have reapportioned that of M to S and to all other production departments. Now that we have apportioned or reapportioned M, M has been eliminated. So nothing can be given to M anymore. And so we are going to be reapportioning S. So this is what we do. Reapportion S. So normally it was supposed to be in this ratio 15, 40, 27, 18. So this is 15, 40, 27, and 18. So now the problem is, if we do it this way, we are using the continuous method and not the elimination method. We said before that M has been eliminated. And so if it has been eliminated, this should not be 15% anymore. It should be 0%. So this is going to be 0 is to 40 is to 27 is to 18. So, but here is the catch. If we are to add 40 plus 27 plus 18, it will give us 85. It will give us 85. It was this 15 that was here that made it 100. So instead of saying over 100, which is percentage, you can say over 85. So 0 over 85 is 0. So it means this is going off now. 6,800 is going off. If we share it 0%, here will still be dash. Okay. So 40%, now it's not 40% per se. 40 over 85 of this figure is what is being shared. to the first production department. So we have it here. 40 divided by 85 multiplied by 6,800. And that gives us 28,612. 28,612. So I'll call it here 28,612. We'll do the second one. I will say 27 divided by 85 times 6,800. Now that is 19,313. 19,313. And the last one, 18 divided by 85 times 6,800. That should give us something 12,875. 12,875. Okay, so now let's add these three and let's see if we are getting something that we bargained for. I have 12,875 coming from right to left plus 19,313 plus 28,612. That gives us the 6,800. So when we do that, this is now dash. This will now be dash. And let's do the next one here. We have 274,000 plus 28,612. That gives me 302,612. Then we do the next one. 441,680 plus 19,313. That gives me 460,993. And the last 563,520 plus 12,875. That gives me 576,395. 576,395. Now I want to add up all of these to see. I have from right to left. And it gives me the same thing here, 1,340,000 overhead. But now, can you see something different? Let's check P1. In the continuous method, P1 was 300,801, and now it is 302,612. In the P3, let's see P3, 577, 487. Here is 576. So it gives you different method, different answers. Some people are of the opinion that the elimination method is less correct or less accurate. But you should know that most times all of these apportionment method used here are estimates. So you can't be 100% accurate. But you see here that despite the way it is being used to apportion or reapportion the service department cost to the production, the total overhead is still the same. So we have seen the elimination method, and this is one of the ways that you might likely see it in the exam. Using the elimination method is far less stressful than the continuous method. So we will go to the next method, which is the simultaneous equation. So the next method here is the simultaneous equation method. So we say using simultaneous equation to reapportion service department costs to production department. Okay, so how do we use simultaneous equation? So this is what we are going to do. So this is going to be our M. This is going to be our S, P1, P2, and P3. The original values for M is 136. So I will say original overhead. This is 136,000. S happen to be 54,000. P happens to be 240,000. Then P2, 390. The first one was P1. Second one is P2. And the third one, P3, is 520. Now I will leave enough room and go down to do workings. So I will come here. How much room should I leave? Of course, here I will reapportion M, and we know the proportion here. The proportion for M was 5, 25, 38, and 32. 5, 25, 38, and 32%. When we're done with that, we'll get our values. Then we will reapportion S, and we know it to be, I think it's 15. Be sure. 15, 40, 27, 18. 15, 40, 27, and 18. And after reapportioning, you will get your total overheads. So let's come here to do our workings. So we have workings. Now we know that since M and S are servicing each other, if M is servicing S, that means we will have S in M. So we are going to form two equations. If M is servicing S, what is the proportion of M that will be in S? 5%. 5% will be in S. So that's what we're going to do. If M is servicing S, if we are reapportioning M, S will have 5%. S will have 5% of M, while M we have 15%, while M will have 15% of S. So how do we do that? So M is equal to 136 here, 136,000 plus anything we are giving out from S. S is being reapportioned, 15% of S. So we say plus 0.15 of anything S is getting, of any value of S. So M is 136, which is the original, plus anything that S is giving as a value. We call this equation 1. Then your S will be 54,000, 54,000 plus, when we are reapportioning M, S is getting 5% of anything M is, any of M value. 5% of M value. Now, this is a better way of doing the continuous method. But instead of using continuous method, we use the simultaneous equation. So this is equation 2. So all I will do now is to rearrange all of these to bring your unknowns to one side and your knowns to one side. So it means that M is here. M will retain its position here. Then there is S here, it has a plus sign. If it goes to the other side, it will become minus 0.15 S. 136 will retain its position. So the only thing that moves is this S. M is still where it was. 136 is still across the other side of the boundary. The only thing that moved was S. S has a visa. So it moved and changes currency from plus to minus. So this is still equation 1. Then S add M in equation 2. Now S will retain its position before the equation sign. So look at where the equation sign is. S will retain its position. So let's put S here under this one that have S. Okay, this 54,000 will retain its position. But what is going? It is this M. It has plus. When it moves, it will become minus. Let's write the M. Let's indicate the M first. So we have 0.05 M. But of course, it's going to be minus 0.05 M. So you see here, you have done them like this. So this equation 1, equation 2, in a conventional way. We can use the substitution method or the elimination method. Okay, I can use the elimination method. If I want to eliminate S, what can I do to eliminate S? I will need to multiply equation 2 by this coefficient here by 0.15. Maybe I will do that now. I'll say multiply by 0.15. So I will come back here and put my equation 1 minus 0.15 S equals to 136,000. This is still my equation 1. Then equation 2, all I will now need to do is to multiply every value by 0.15. So I'll say 0.15 multiplied by 0.05. 0.05. Remember, there's a minus here. So this is 0.15 multiplied by minus 0.05. That gives me minus 0.0075. Minus 0.0075 M. How many zeros are there? Altogether 3 zeros. That's fine. Now 0.05 times S will give me plus 0.15. So when there is just S there, it's taken as 1S. So 1 times 0.15 will give me 0.15. Then we have 0.15 times 54. 0.15 times 54,000. That will give me 8,100. 8,100. So what do we do? So this has a minus sign, this has a plus sign. How do we eliminate S? We just simply plus the whole, we plus them. So M plus minus 0.075 is the same thing as minus. So plus and minus gives you minus. So what it means, this 1M, so I will just say 1. If I say plus 0.0075, remember there's a minus to it. So 1 plus minus this will give me everything here without the minus. So 0.9925. 0.9925 M. Of course, here will be 0 and here will be 136 plus 81. I have 81 here plus 136,000. That gives me 144,100. 144,100. So what would my M be? M will be 144,100 divided by 0.9925. So what would that be? I have 144,100. So I'll just go straight ahead and divide by 0.9925. That gives me 145,188, 189, 145,189, 145,189. If that is for M, I can still use the same method to look for S. Or instead of doing that, I'll just put the value of S in this equation 2. I'll just go straight to equation 2. I'll say S is equal to 54,000 times 0.025, 0.05 M. 54,000. So I have 54,000 plus 0.05 M. So this is 54,000 plus 0.05. Open a bracket, put your value of M here, 145,189. So this is going to be 54,000 plus, I have this long answer in my calculator. I'll leave it that way. I'll just multiply by 0.05 and I have 7259, 7259, 7259. So when I add it to 54,000, I add to 54,000, I have 61,259. So this is 61,259. So that is your S. So that's one method of doing simultaneous equation using the elimination. We can decide to use the substitution method. So let's look at the substitution method. I have M 136 0.5 S. So I'll say M 136,000 plus 0.15 S. This is equation 1. Then S is 54,000 0.05 M. So S 54,000 plus 0.05 M. That's equation 2. So if I want to eliminate S, or I want to find M first, if I want to find M, all I need to do is anywhere I see S, I'll put the whole of this. So to find M, so I have M is equal to 136,000 plus 0.15. Now in place of S, this is S. I'll put the whole of this. 54,000 plus 0.05 M. So this will give me M is equal to 136,000 plus, I will now use 0.15 to multiply everything, 0.15 multiplied by 54,000. That will give me 81 as we got before. 8,100 plus 0.15 times, so I'll have 0.15 multiplied by 0.05. That will give me 0.0075. So that will give me 0.0075 M. Okay, so this will now be M. Now this one is going to join to meet its brother here. It has a plus, it's going to be a minus 0.075 M, which will give me 136,000 plus 8,100. So your M, okay, so what happened here? This is like saying 1 minus 0.075. So if I minus it from 1, it gives me 0.9925. So this is 0.9925 M. Add all of these together. 136,000 plus 8,100. That gives me 144,100. 144,100. So our M is going to give me 144,100 all over 0.9925, which will give me what? Okay, divided by 0.9925. That gives me that 145,189. 145,189. So we've gotten the same answer that we did here. Then all we just need to do to find our S is to use the same equation we did exactly the way we did it here. Exactly the way we did it here. We'll put 54 and we'll just do exactly the same thing. So no need repeating it here, and you're going to get the same answer. So when you've done this, it means that M is 145,189. So this is what you are giving out of M. Remember, M was 136. If you are reapportioning M, you are reapportioning how much now? 145,189. So let's do that. We will say 145,189. That is what we are reapportioning. So we'll use 5% of this for S. So I have 145,189 multiplied by 0.05. That will give me 7260. 7260. Okay, I can decide to say 59 instead of 0. I can decide to say 59 to save myself stress. 7259. Yeah, it's 7259, not even 0. 7259. It's not, this is not up to 5. So it's 7259. Beg your pardon. 7259. 7259. Okay, then I will come here and 25%, 25% multiplied by 145,189. And that will give me 36,297. Okay. Then the next one should be 38%. 145,189. That will give me 55,172. And the last one, which is 32%, multiplied by 145,189. 46,460. So let's add. If we get this figure, if we don't have it, we find a way and adjust it. I have 7,259 plus 36,297 plus 55,172 plus there's something we did wrong. So let's recalculate again. I have 145,189 multiplied by 25%, 36,297. Okay, 145,189 multiplied by 38%, 55,172. Then I have 145,189 multiplied by 32% now, 46,460. Okay, let me add again. 46,460 plus 55,172 plus 36,297 plus 7,259. Good. 145,188. So I'll just give this one here 172. I'll make it 173. So I'll just add that one here. All of this because of rounding error. So I've done that. So when I do this here, so we are going to add, so this is my figure here. It has a negative value. If I add it to 136,000, so I have minus 9189. So I have 9189 minus, if I add this to 54,000 plus 7,259, it gives me 61,259. 61,259. Now, I want to show you something before I go further. 61,259. If you go to a value of S, that we got 61,259. That is what we are reapportioning. So when we apportion the whole of what we've given S from M is this. And if you add it to S, it gives us 61,259. We're on the right track. We have 240 original plus what M gets, what we get from M, 36,297. That gives me 276,297. 276,297. Then we have 390 plus 55,173. We have 445,173. 445,173. 445,173. Then we have here 520,000 plus 46,460. We have 566,460. 566,460. Okay, so now we are going to reapportion S. Of course, it's going to be 61,259. Remember when we reapportion M, this was the total apportionment of M we did. And we've seen how it fizzled out to other departments. This is the apportionment of S we are going to do, and this is how it fizzled out. We are going to reapportion this. 15% will go to M. So we'll have 61,259. Sorry. 61,259. We look for 15%. Now, if you look at it now, it is 9188.8. So it is 9189. So we have our 9189 here. 9189. So you see, this one will knock off this and it will become 0. This will knock off this, they will become 0. So let's apportion the others. 61,259 multiplied by, we have 40%. That will give me 24,504. 24,504. Then we have 27%. 61,259 times 27%. That gives me 16,540. 16,540. And the last one, we have 61,259. How many percent is that? 18 times 18%. 11,026. I'll say 11,026. So this is 11,026. Let me remove this 4 here. I'll make it 3. You know, the last time we allocated Where did we allocate the higher value? It was this one that we allocated the higher value. Okay, it was this here. It was this P2. We allocated higher value. Okay, it was P2 we allocated higher value. So let's also allocate, let's remove that higher value we gave it. So we can still leave this one here as 504. So that's one that we gave it there before. Let's come here and remove it. So instead of 540, let's call it 539. So that way, we don't give it, we know it is 540, but we've given it one before that we are not supposed to when we approximate. And let's remove that one. So everything is now in order. So let's have it down. Let's calculate 24,504. Sorry, 504, which is this, plus 16,539 plus 11,026 plus 918, sorry, 9189. Okay, so let's give it that 40 we have. So I'll add the one back. So let's give it that 40. It was actually correct. 16,540. So it was actually correct. All right, so when we do this is minus and we have the same figure as plus, gives you nil. This is plus, we have the same figure as minus, gives you nil. We now add the others. So we have here 276,297 plus 24,504. That gives you 300,801. 801. Then it come here and do 445,173 plus 16,540. That gives you 461,713. Let's do the last one. 566,460 plus 11,026. 577,486. Let's add them together. So 61,713 plus 300,801. That gives you the same thing. Now, notice something here. I want you to notice this simultaneous equation. Look at this P1 value, 300,801. Let's compare it with that of the first one we did. Let me compare the first one we did, which is the continuous method. 300,801. Let's look at this second one here. 461,712 461,713, just one here, and this one is that other one here. This one is because of the one we gave it the first time. So if we have approximated and given this other value, if we have given this 3, if you have given it to this, and it becomes 61, and we give this one 72, it should have given us exactly the same thing as we had in the continuous method. So the continuous method and the simultaneous equation method are the same. But which one is less stressful for you? Going to continuous apportionment or going through the simultaneous way, getting the value of M and S that should be apportioned, then you reapportion just once for the two of them. Which one is going to give you less stress? Simultaneous equation or the continuous method? If they ask you in the exam to use any method to calculate, you can choose any of these 3 that you can remember. If the question specifically asks you to use the continuous method, do it that way. Ask you to use the elimination method, use it that way. Ask you to use the simultaneous equation method, use it. But we said the elimination method is best suited when the service departments are not servicing each other. When they are not servicing each other, all we need to do is elimination method is the best. When they are servicing each other, elimination method is less accurate. The continuous or the simultaneous equation is far better or more accurate. But in the exam, choose whichever one you like to do. Note that in the elimination method, when you have eliminated one using 100%, it goes out. When you are eliminating the second, when you are doing the second reapportionment, it's not going to be over 100. It's going to be over the remainder of the fraction of the ratios that you are using or the percentages that you are using. So that means the one that has been eliminated will have, we assume, 0%, and life goes on. So that's it. But there's a way you can make the elimination method perhaps more accurate. It is to this 15% can be reapportioned to these others using their proportion. So it means that this 40% will increase a bit, this 27% will increase a bit, and this 18% will increase a bit, and we'll now use over 100. If you do it that way, you are going to have the same answers with what you have in the simultaneous equation. But that's not the method. This is how you do the elimination method. So thank you so much for your presence here in looking at how we do a secondary reapportionment, which is the main aim of this class. How we reapportion the service department into the production department, shows that the service department has no cost at the final analysis. The 3 production departments have holds the costs, and the total overhead cost did not change, only that it is apportioned or reapportioned differently using the 3 different reapportionment method. Thank you so much for joining me in this class, and please like our pages on social media, subscribe to my YouTube channel, and join me on WhatsApp This is my WhatsApp number. Let me give you a number, my WhatsApp number, so that you can contact me at any given point in time to ask your question. That's my WhatsApp number. This is my email address. And I remain my humble self, chinwaji. So, thank you so much and have a great day.